with Maharashtra Energy Development Agency and Gujarat Energy Development Agency. He also published more than 50 papers on conservation of energy in national and international journals and periodicals. He conducted more than 500 training programs on conservation of energy for industries, educational institutes, and others. He also carried out 1,500 energy audits and energy conservation studies over India and abroad. With this brief introduction, I welcome Datar sir for this session and I request him to start his session.
Yeah, good morning everyone, and I must thank Dr. Khoth and his team for giving me this opportunity. And we already lost some 10-15 minutes, so I think we'll go to the topic directly. What I'm going to talk is about the energy audit instruments, which instrument and what precaution one need to take while selecting and using the instruments. I think the first part is more important because the energy audit instrument, many of the people would as such be aware, but anyway we'll cover that. So we will see the basic fundamental requirements while doing the measurements. Audit, you already had a session with Mr. Ashok, who is a renowned and very senior person in this field. Now we will see the basic things what we need to look. First is the accuracy, accuracy of the reading. Whenever we are doing any measurement in audit, the reading has to be accurate so that whatever conclusions we draw, they are accurate. If the readings are not correct, then all the conclusions can be erroneous, and maybe the saving projected also could be wrong. Now, accuracy, there are 4 or 5 parts. First, I'll just give you a simple example which I had witnessed myself. I had a very old client. Old meaning I was working with him for almost 20 years. It's a big industry located somewhere in Orissa, and we had done audits for them even a few years back. So last time they said we will get the audit done from somebody else, but why don't you come for 2 to 3 days to see that the work is going on properly and put your input, because you are with us for so much of time. So I went to the site after the audit was started. The audit team had already initiated the work. It was 2-3 days after the audit was initiated. I visited the facility. I had a round with their people, and now I was going not as an auditor but as a person from the company side. So during the visit, the audit team was doing measurement of chill water system. They're doing a performance analysis of refrigeration chiller. As you know, that chiller performance, the most important thing is chill water flow rate and chill water temperature, and of course power consumed by the chiller compressor. So based on this, we can find out what is the COP, energy efficiency ratio, specific power consumption, whatever name you can give, that can be found out. So why they were doing a measurement of temperature. Now temperature measurement they were doing with a thermocouple having a range of 0 to 600 degrees centigrade. So I asked them, why are you using this instrument? Because I thought 0 to 600 degree thermocouple is not appropriate for doing such kind of measurement. They said, no, sir, the RTD is occupied somewhere else. So we said, might as well use this instrument. So we using it. Then I asked them, and I asked their company person also, do you know what is the accuracy of this instrument? The accuracy of thermocouple, typically, what instrument they had is 0.25%, which is good. Many of the thermocouples, the accuracy is 1%. And mind you, the accuracy is generally defined as a percentage of full scale reading. So when you say that the instrument can measure 0 to 600, that means the full scale reading is 600. Now, if you take 0.25% of 600, it comes to 1.5. So that means whatever reading they were taking, it could be wrong by 1.5 degree on either side. So in this particular case, the reading was 9. So that means the temperature could have been anything from 10.5 to 7.5, because that is the accuracy of the instrument. the chill water temperature at the outlet was 4 degrees. Again, that could have been plus minus 1.5. So the delta T what they got was 4. You know, when you minus that 9 from 5, you get 4 degrees. That's a delta T. And that could have accuracy of plus minus 3 degrees. Because these plus minus on both sides, because we are doing two measurement, it gets added up. So it could be plus minus 3 degrees. So what they measured as a 4 degree delta T could be anything between 1 degree to 7 degree. Now, can such analysis be correct? You know, it's a very simple question. Now, when we do analysis and we try to project saving based on that delta T, so instead of 4, it can be anything between 1 to 7. That means whatever we have done measurement, whatever effort we have put in, those efforts are gone waste because we are not selected a proper instrument. So while selecting the instrument, the first thing we need to look at is what is the accuracy of the instrument. And accuracy of instrument is defined uh, in two ways. You know, normally when we buy instrument, they say, okay, this is having a 0.25% accuracy. But many times the manufacturer fails to say that it is percentage of a full scale reading. So full scale reading mean whatever is the full span of that instrument, that is going to be the value and not our reading. Some instrument, of course, if you see, there are some sophisticated instrument which will say that plus minus 1% of the reading, or they'll say both the things, you know, plus minus 0.1% of the reading, or plus minus 0.25% of the FSD, whichever is higher or lower, you know, that is available. But when we buy an instrument or when we select the instrument, we have to see what is the accuracy of the instrument with respect to the reading we are taking. We need not go purely by saying that this instrument is accurate, it has 0.5% or 0.25% accuracy, all right. But what reading you are going to take with respect to that, how accurate your values are likely to be. Now that needs to be analyzed. And as a part of that, the rest of the things will come. You know, range again is the maximum and minimum values and intermediate values of the instrument. Like as I said, the thermocouple is 0 to 600 degrees. So the range is from 0 degree to 600 degrees. You can do the measurement in the range of 0 degree to 600 degrees. Now, when you are having such kind of instrument, we have to see the importance of the measurement. Like suppose we are doing the measurement of surface heat loss for a furnace. Now, surface heat loss of furnace, normally the furnace temperature is supposed to be about 60 degrees or 65 degrees, depending on the furnace internal temperature. Now, when it is 65 degrees plus minus 1.5 degree or plus minus 2 degree, it is not going to impact to that level in your analysis. Because as such, insulation losses are not expected to be more than 5% or 6% of the total losses. So if your reading is plus minus 1.5 degree, it probably will not make that much of difference, because the criticality is different and also the values and range are different. So accordingly, we have to select the range of the instrument and application of the instrument. Third is span. You know, span is anyway the difference. I think most of the people, you are from probably academic background, so most of you would be knowing all this term. I'm just trying to highlight the application part of it, which is very critical when we are doing energy audit. The third part is the least count. The smallest value that can be displayed is a least count. Say, for example, we are using a same digital temperature indicator having 0 to 600 range. It will display 1 degree as a minimum. So that is the least count of the instrument. It will not display anything less than 1 degree. If it goes to 1.5 degree, it will go to 2, maybe, or it may be 1 only, depending on the how the thing is configured. But it cannot display any decimal value. That is the least count. If you take a RTD based instrument, which is normally used for chill water readings, it could show, it could have a 0.1 least count. There are instruments which could have 0.01 least count. So the least count will give you the kind of, the extent of reading you can get, and that also indirectly reflects on your accuracy and quality of the reading. The next is a resolution. Resolution is basically when we are doing a measurement, there are two parts. One part is a sensor, which is basically probe, what you call it, and another is a display unit. So resolution is the characteristics of the sensor, whereas the least count is the characteristics of the display. So resolution is the smallest difference in the variable. So when we are measuring a temperature, the variable is temperature. So if the temperature from 4, if it goes to 4.1, and our sensor can pick it up, that means it has a resolution of 0.1 degree. If our sensor can pick up 0.01, then correspondingly the resolution of the sensor is 0.01. Of course, when we are buying a handheld or portable instrument, they will match the least count and resolution so that ultimately we get the correct value. But many times we do data logging also, where data loggers are separately procured and sensors are separately procured. So there this aspect comes to play, that when you're buying a sensor, we have to see the resolution part to say that what is the least difference it can measure, the variation in process, how much accurately it measures, to what decimal it can measure. So these are the things we need to understand and take care of. The next is basically repeatability, reproducibility. They say that maybe there is a small difference here and there, but in industry they are used interchangeably. When you take multiple readings of the same temperature, same thing, if you take multiple readings, how close they are with each other, that is a repeatability. So the instrument, so let there be error. Suppose the plus minus 1% accuracy or plus minus 0.25 accuracy, but for the same water, if you dip that thermocouple and take the reading, is it showing the same reading every time, or it is showing different reading every time? Without changing the temperature, if you just dip the instrument, take it out, again dip it, whether they are showing same temperature, same value or not, that is a repeatability of the instrument. Precision is on the reading side, that is the basically closeness of the measured values with respect to each other. They are again similar sounding words, but this is on process side, that is on the instrument side. Then sensitivity of the instrument, that is how quickly or how effectively the changes are get recorded. If there is a small change, suppose the temperature goes up from 100 degree to 120 degrees in 1 minute, how much time our instrument will take to record a similar change? Can it show instantaneously? No, no instrument will show instantaneously. It is going to take some time. Now that time lag basically would depend on the sensitivity. More sensitive the instrument, it will show it quicker. Less sensitive the instrument, it will take slightly more time. So this one need to take care, especially when you are doing a higher temperature readings, or where you are doing a humidity or such kind of reading. Humidity or wet bulb temperature, those reading normally take more time than simple temperature. And when you want more accurately, probably you need to be more careful about the sensitivity of the instrument, because the audit team has a tendency of not waiting for long enough to see the reading stabilized. Then basically the linearity. Linearity is the proportionality of the signal output with respect to the change in the variable. Suppose the temperature goes up from 100 degree to 200 degrees, so it is doubled. So is the signal from the sensor also doubled, or it is change in some other proportion? That is the linearity. And for accuracy and for better reading, it should be linear. So if the changes is proportional to the square or some obnoxious value, or the correlation is not linear, it becomes slightly more complicated to get the correct reading. So most of the instrument will be selected to operate in the range where the relation is linear. Now we'll come to some basic requirements when we are doing measurements or when we are handling the instruments. First is the calibration. Calibration is essential, because calibration is what we are doing is we send the instrument to a recognized laboratory, maybe having a traceability with the NABL certified instruments. What they do is they send their master calibrator instrument to the NABL accredited laboratory to get it tested, so that their instrument master calibrator is accredited by NABL. So it has a traceability that it is calibrated against the instrument which is done by NABL. So that is the calibration. So when we are sending the instrument for calibration, we need to see the accreditation of the calibration agency, because there are many people who will just give a certificate without even sending the instrument. Now I am in this field now for 30 years. We have seen all kind of people. So that is a really short-sightedness, because we do so many measurements. So it is always better to have the instrument calibrated. So our instruments are normally calibrated once in a year. But if and suppose we have a doubt on some readings, which we feel is not matching, or the client feels somewhere there is a problem, we try to verify against our another instrument, or then we send it for recalibration even less than 1 year period. So calibration is essential to validate that what reading we are getting is correct. Our instrument doesn't have any fault, because audit is the exercise based on which the client is going to take major decisions about investment changes and all that. And if our readings are not correct and what we suggest is on erroneous data, then ultimately it is going to land the client in a problem, because after the modification the system doesn't work properly, then it's going to be a financial loss for him. A face loss for us is very small, because we can always say something has changed, something is not changed, but it's a major loss for the client, and we should not get indulged into such kind of thing. So all the instruments need to be calibrated properly through a accredited lab having traceability to NABL. Now, there are certain things we need to be very careful while doing the measurement. Now, one of the things is the location. Where do we take the measurement? Now, depending on the type of measurement we are doing, there are certain norms specified by the instrument manufacturer, specified even by Bureau of Energy Efficiency. If you go through those books, they will also provide certain norms. But most of the time, it is the instrument manufacturer or standard operating norms which need to be followed. Here again, I'll share one example. We are doing audit for a very large company, and they had huge cooling water system. Now the cooling water system was used. The pumps were in literally in megawatt was the pumping load, and they had a huge pipeline, almost a 1 meter diameter pipeline, common header, through which we need to measure the flow. And the pipeline, after certain distance, maybe after 2-3 meters of distance, it was basically underground till the condenser, and the condenser it was rising. And the straight length specified by manufacturer is normally uh, about 15D and 5D, 5 times diameter after the measurement and 15 times diameter before the measurement. So it's slightly here and there is acceptable. But in this particular case, the straight length was very small, maybe 3D or 4D, somewhere in that range. So I told them that this is not possible to do measurement at this point. What we can do is cooling water return line again was underground, and there were risers, from the underground line. They had some 10 or 12 risers which was feeding the water to the cooling tower top. So there the diameter was marginally less, and we had straight length available. So I suggested, why don't we do the measurement along the risers? There are some 12 risers, so we'll take the measurement at 12 risers and add that and take a total value and calculate the common efficiency for all the pumps. It is not possible to do it for individual pumps because of the non-availability of length. But the client and their engineering manager insisted, saying that let us do it and see what happens. What happens, straight length is not there, what is going to happen? Maybe there is a 10-15% or 5% error. I said there will be error. Now whether it is 5% or 20% or 15%, how do I know? Because it is not recommended by the instrument manufacturer, by the general practice. You search anywhere in the net, they'll say that flow measurement, this has to be a straight line. So there are reasons, and I try to tell him that there could be eddy current, there could be disturbance which will not provide you a correct signal. But he insisted. We did the measurement, and the pump efficiency was coming pathetic. We were getting efficiency of around 30%. The flow was coming very low. And I told him, anyway, these readings are not reliable. I am doing it because you have suggested. And but we still called the OEM, of course, on phone. We didn't, OEM didn't come there on the site, but we talked to the OEM. We saw the curve, we saw the power consumption, and nothing was matching. So ultimately, then we decided, okay, let us know whatever has happened. We'll do the measurement for the risers, and we did the measurement at the risers, which was more or less matching with the design values. So the flow was almost 30-35% more, which was as per the design, against the what value we have measured earlier when that wrong location was coming 30% less. So location matters, or anybody puts any pressure or anything he says, ultimately we are answerable to the industry, we are answerable for the saving and what we are looking for the saving. So it is essential that we resist such kind of shortcuts or temptations to carry out the measurement even at incorrect location, where that is not going to yield correct reading, and it's not going to yield the suggestion is not going to be correct. Another is placing the instrument or fixing the instrument. It should be securely fixed. Otherwise, if it is not done properly, the reading can be wrong. Again, here I'll give you example here also, because instrument part is simpler. It should not be too much of concern. Here we are doing audit for a power plant flue gas analysis. So flue gas analysis, we need to measure carbon monoxide temperature, oxygen content at different locations along the duct. So our team member, we went and they tried to take oxygen measurement. And because it was a big plant, they had a power plant also. They had their own online display also, so that the instrument, on DCS also, the oxygen content and CO level were displayed. So when we did the measurement, our oxygen was coming considerably higher, indicating that excess air is much more, is what our instrument was showing. Whereas in their DCS, the values were correct. They were showing around 3.5% oxygen and 300 ppm of carbon monoxide, whereas what we are showing was almost 8%, 8.5% oxygen and correspondingly less carbon monoxide contents. So they started asking why there is a difference. Then I said, let me go and see, because I had not gone to the site. My team had gone and they were doing the measurement. When I went, what I saw was the probe was inserted, but there were some gaps. Now you would be aware that all the entire ducting system is under negative pressure. Now if you don't seal it properly, the air from the atmosphere is going to go inside. Now that air goes inside and occupies the space close to your instrument, because it is going to mix with the flue gases at some distance, then it's not going to matter, because you have more than lakh meter cube of gas going. Few ml or few liters of ingress is not going to show, but at that measurement point it was showing, because that's where that air was entering from. So that was the reason why we were getting a wrong reading. So I asked them to seal the thing properly so that the ingress is totally stopped. And after that, we got similar reading. So such kind of thing can happen. That if you don't fix the instrument properly, you don't insert it properly, you don't seal it properly, the reading could be erroneous. And again, if you go by that judgment, then it is going to be wrong. Now, another incident happened with us was very long back. It is maybe about 20-25 years back. Now we are doing first time we are doing audit for a big furnace, sorry, which had a heat recovery system. So normally what happens, you know, when the furnace temperatures are 800, 900 or 1000, the flue gas coming out is at almost 1000 degrees. So there is an internal refractory on the duct. So the duct will be refractory line. So inside the duct there is a refractory line, then there is a casing, and after that there is some small insulation they had, which should not have been, but they had. So we tried to take the measurement, we are not getting any reading. So when I went there to see, I saw that it has a refractory lining of maybe 200 mm or something, and we had a short length probe. You know, earlier time when we started audit, the normal length of the probe was 300 mm. So that is, of course, I'm saying 20 years back, not today's situation. So 300 probe was not even going inside properly to take the reading, you know, because normally there is a 4-inch nipple, then there is a 200 of refractory, then casing, some insulation. So it was not even properly going inside the duct. It should at least go till center or slightly less than center, but it was just touching the circumference probably or somewhere in that range. And that was the reason why we were not getting the correct value. Of course, now we have long stem probes, you know, 700 meter, 1 meter length. So it's not a problem, but that time it had happened. The next is validation of the measurement. See, all said and done, we are doing measurement for certain period of time. And it is quite possible that the measurement can be erroneous if the values are abnormal. If everything is in normal range, you get a pump efficiency normal. If you see cooling tower performance normal, chiller normal, then you don't doubt so much. But if there is a abnormality, if you see that suddenly there are no, there's pump is having just giving 20% of the flow rate, or somewhere you see that no, this temperature is way high than what it is, then it could be possible that there is a issue with measurement. Now that is where, you know, especially whenever there are abnormalities, because see, abnormalities cannot be avoided, because that is where the saving comes. Because saving will come from abnormalities. If everything is normal, then where's the saving? Unless you say replace it. You know, you say that you have very nice AC, but it's a 0 star or 1 star, and is running as per the design conditions. What you're going to recommend is you upgrade to 5-star or whatever VRV based or the drive based AC. So if there are no abnormalities, there is no saving. So we cannot push the abnormalities below the carpet. They are going to be there. They are where the saving comes. But abnormalities can also be because of our errors. So when we are doing audit, we have to ensure that when you are doing measurement, when you are doing audit, we have to ensure that we are eliminating wrong, the incorrect presentation to the extent possible. And for that, we need to validate the measurement. There are always ways and means of validation. You are all from technical field. I don't have to say that, but simple laws of conservation of mass, conservation of energy, you know, that will help you in finding out the validation part. And we have been doing it since quite some time, that whenever we get some readings, whenever we have a data and feel that this data may be erroneous or there are abnormalities somewhere, we try to validate the measurement by many methods, you know, by indirect method, by direct method. Sometimes we recheck the values. Sometimes we talk to the process people and try to understand their views, whether there are any problems, where there are any issues. And based on that, then we make the final here again I'll give another example where we're doing some audit for a medium-sized company, and we are doing a compressor capacity test. I think Mr. Ashok must have already told you compressor capacity test is very simple. They call it a pump up test. That is just switch off, depressurize the system, Start the compressor, pressurize it, see what is the time involved, note down the volume, and from there you can calculate FAD or the capacity of the compressor. And we did the same test, and that value was coming very low. The compressor capacity was coming some 50% or somewhere in that range, which was quite abnormal. So we thought maybe we are wrong. So we started talking with their process people, but they agreed with us. They said, yeah, there may be a problem because 6 months back we were running only one compressor. Now we have to operate two compressors for the same load because nothing has changed. So either the leakage are increased or the compressor capacity has gone down. Then, because this problem was validated by the plant people beforehand, they called the service engineer for the compressors. Now the service engineer came, he checked the compressor, he opened the thing, and then he saw that some non-return valves had got damaged. So non-return valve was not functioning. So the piston was just moving backward and forward, but the air was not getting delivered. That was the reason. So that they rectified, and then the saving was validated, and they got the saving. But we always try to check, because 50% capacity compressor suddenly means there can be some other issue also. Okay. Then comes the time of measurement. Now, this becomes more critical for large plants, but otherwise also, when we are doing a measurement, we have to see that the process is at normal condition. If there are some deviations in the process, if there are some variation in the process, corresponding there are going to be process equipment variations. Because say when you are doing a chill water capacity test, you're trying to find out what is the TR of the chill water, and if the plant doesn't have any chilling load, then definitely it is not going to show you correct readings. It is going to show that TR is less, KWHP TR is high, but which is not a normal case. So that is why whenever we are doing measurements, we need to ask the people that is everything normal? Is there any abnormality in this system? And when we do audit for the power plant, or when we do audit for caustic plant and such, even cement, we always ask and write in our report that this is the rated operating capacity of the plant. So sometimes it happens that when you're doing some measurement, the rated operating capacity is 100%, sometimes it is 80%, but that is reflected in our data sheet so that they also know that this measurement was done at lower plant capacity, this was done at uh, full capacity kind of thing. Then basically comes the how many readings we should take. Now, sometimes what happens, when the criticality is higher, especially it happens for flow measurements and other measurements, where suppose the reading is very critical and showing some variations, because you say we connect the flow meter and the flow is varying from 200 to 220 meter cube. It can happen, it can happen because of many, many parameters. We will not discuss that now because then this will be another topic for the presentation, but it can happen. So what do we do under such conditions? If it is varying from 200 to 220, now for the pump analysis or a chiller analysis or cooling tower analysis, what values do we take? So there are two options. One option is you take some readings, some 8, 9 readings or 10 readings at 5 minute or 1 minute interval, find out average. Another method, what we normally use, our flow meter has a totalizer. So you activate the totalizer function, you do it for 10 minutes and then average out so that the measurement calculations, everything is based on the average value. So this again need to be assessed. Similarly, when we are doing a power measurement for a reactor, now if you see a chemical plant reactor, the load keep on varying. Depending on the content inside, viscosity, temperature of the material, the volume, like the total contents in the vessel, the viscosity of the material, and other things, the power drawn by the drive can change. So then we have to do measurement when it is at normal operating or full operating conditions. Sometimes we do it at two levels. One is a minimum, average, and maximum. So that accordingly the suggestion can be made. If there are now voltage optimizers available, there are some star delta converters available. So the correct suggestion can be given and they can actually get the saving. Duration is the same way, earlier it was time, then we say duration. So if it is required to be logged, we log it. Now this logging also becomes critical for say textile, pharma industries, where they are trying to monitor temperature and humidity. So now there are temperature humidity loggers available, which are not very expensive. So we leave them inside, even in data center, because measuring for few minutes is not going to give you correct value. So we place the data loggers at appropriate locations and capture data for 24 hours at maybe 1 minute interval, 5 minutes interval, to see the variation or profiling of the thing. And based on that, many times suggestions actually can be given. Some case, I'll tell you, it had happened that we were doing audit. It was for office building. We were doing audit for that office building, and we had a we're doing logging for electrical parameters. We're not doing for the iris temperature. And what we observed that during the 24 hours, the office was running from maybe 9 o'clock to evening 7 o'clock. And at night, it was a standard building. So at night, some lighting and some security thing and data, that server room, they were on. And that day that will consume certain power. So we carried out power logging for 24 hours. And what we saw that up to 9:30 or 10 o'clock, the consumption is quite high. So average consumption during day was say 1000 kilowatt. Then from 7 o'clock to 10 o'clock, it was about 600 kilowatt. And after that, it was around 200 kilowatt. So we were surprised that 7 o'clock is a normal office closing time, 6:37. And why this consumption is higher during this 3 or 4 hours of time. Then when we analyze that, we came to know that some of the top people, they sit late, till 9 o'clock. That's a normal habit in many of the businesses. So 90% of people would leave, but the 10% people would be sitting there, or 5% people may be sitting there. And for them, the entire central AC was operational. And that was leading to such a high consumption, that 600 kilowatt or 700 kilowatt for that 4 hours. So just for a few people, they were consuming 400 into 3 hours. Even if you take it, was almost 1200 units a day they were consuming from. So when we highlighted this point to the management, they immediately changed the methodology, and based on that, they had some smaller unit for the top bosses, and the main AC was closed on. Some AHUs were left on, and they could save on this energy. So this is where the duration becomes important whenever you are seeing the variations. Then of course the condition and handling of the instruments, that is we need to take proper care, because auditor has extensive uses, and there are many people who are handling it. It's not is a single-handed thing, like say that instead of car you have a taxi. Definitely the handling is not going to be same. Personal car and taxi, that's a difference always there. And many times instrument, the cable can internally break. There may not be any visible damage on the cable, because that cable has a protective covering, but internally there can be a damage. It can break, it can be slightly damaged, and that could affect the reading. So of course we keep checking continuity of the cable regularly, but still we need to be careful while handling the instrument. And as I would also suggest that you take the continuity test, and do it internally, to ensure that there is no internal damage to the one. Then we need to also study the external environment, especially for air conditioning, cooling towers, and other things. Then for air conditioning, or even as I said earlier also, that you should know the plant capacity, operating capacity, what is the load, what is the occupancy while carrying out the measurement. Validation, I think, got repeated. I didn't delete it from here. And low battery, again, this habit I have seen at few of our team members also, that they say that okay, low battery is there, but the reading is still coming, so let us use the instrument. But that is very wrong. When the battery is low, the reading can be wrong. It is quite possible, we have witnessed it ourselves. So if there is a low battery signal, please ensure that the cells are replaced. Don't go by that display is there, so you will get the reading. The reading can be wrong. Now we'll come to the instrument. I think I've taken more time in this, but I think that this is more important. The instrument many anyway would be you would be knowing about this. We'll see lux meters for light measurement, anemometers, pitot tube, manometers, hygrotemp, sling psychometer, outdated now, but still clamp-on meters, plug-in meters, ultrasonic meters, pressure gauges, flue gas analyzers, and all that. So basically, lux meter is used for measuring the illumination level. It's mostly a neglected part of the audit, because I have seen that in India we are comfortable at lower illumination level than what is required as per the standard. I have yet to come across any industry where the illumination level is higher than what is required. So illumination measurement, lux measurement is a notional thing. Most of the places we end up saying that okay, you put more lights if you want. Otherwise, as you are comfortable, please continue with the present system. But there are some small things we need to take, that meter should be at working horizontal plane. It should not take at random locations, or it should not take it at ground level or very high level. It should be where the people are sitting and working. And take measurement. BW has given a very big procedure and guidelines for doing the measurement, which need to be adhere when you're doing as per that. These are the simple lux meters. I have taken this from internet. I know any special interest in any of the product, any lux meter is okay. It's available from 1,500 rupees to maybe 50,000 rupees. But as I said, I am not very fussy about lux meter, because it is not really, we are not got saving through light reduction in anywhere of my 1,500 or maybe now more audits. So I'm not very fan of this. Now, anemometer is more important. There are basically three types of instrument available for measuring the flow of liquid and air and gases. The commonly used is a vent type anemometer. This is to measure the velocity of air, but mostly it needs at least one side has to be open. Either discharge or suction has to be open to atmosphere. Otherwise, you need a 50 NB or maybe now 25 NB flange connection through which it can be inserted. But inserting it means, some air is going in, some air is coming out. That is not a very good thing. So vane type anemometer is normally used on open side of the suction or discharge. And the working principle is very simple. It is basically like a ceiling fan you have, or a windmill. It is basically the air is rotating the blades, which is generating EMF, and that is that is calibrated to give you velocity. Exactly like windmill. It is giving you power. Here it will just give velocity because this is a small instrument. Then the second one is a hot wire anemometer. This is a specialized instrument normally for clean air at either air conditioning or normal temperature. Basic range is maybe 5 degrees to 50 degrees or 40 degrees. It will not work beyond that. Now, hot wire anemometer has either one or two sensors. Now, it will inject current in that heating element. Now, as the air is flowing over that sensor, it is going to carry the heat. So, based on the temperature, you have one reference temperature. For that, there is a sensor which will sense the actual temperature, and another will be the temperature of the heated element. Now, the temperature of heated element will depend on the flow of air. So, that way it will measure the velocity and tell you what is the velocity of the air flowing over the anemometer. Also temperature, because another sensor is anyway there to measure the temperature. So you will get both the values. You will get temperature and velocity both, whereas vane type anemometer will give you only velocity. Now the special precautions are simple, more or less on the similar line. It should, the position and orientation should be correct. Now, flow direction is important, because anemometers, many times we feel that it doesn't matter. Like anyway, there are blades rotating, or there is a hot wire anemometer. How does it matter? Well, it matters. On the anemometer, they will specify the direction of flow. That need to be followed. Second, then we have to have it, cross section. It should not be tilted or inclined, because that again is going to give you a wrong reading. So while inserting, it has to be exactly at 90 degrees to the flow of the air. So anemometers and vane type anemometers and hot wire anemometers are normally used for air applications from maybe 10-15 degrees temperature to 50 degrees or 40 degrees temperature. And plastic anemometers are not suitable even for cooling towers, because they cannot take that kind of humidity and the connection, because it is EMF is generated, so that point is not, it doesn't take the humidity. So for that, there are some metallic blade anemometers available. We know at least 2 companies who are making it. So that comes with a metallic blade and up to about 50-degree temperature. These are the anemometers. Again, it is from the internet. This is the hot wire anemometer. These are vane type anemometers. Another instrument that is used is a pitot tube. So it is used for, pitot tube has a SS probe. So it can be used for higher temperature. It can be of any length, pitot tube. We have used a pitot tube of 3-meter length also. So it is not an issue to measure the high diameter duct. We can do that. It can be used for dirty fluids. Other two cannot be used. It can be also used for fluids in open channel. It's a separate topic. We don't normally come across in audit. The precautions are on same line. And there are typically 2 types of pitot tube. One is the S type, that is used for a dirty fluid, and L type, that is used for a clean fluids. So this is the S type pitot tube, where the openings of larger side. Basically, what pitot tube is doing is they is measuring the static pressure and total pressure. I don't have to explain probably this to you. There's a static pressure and total pressure, that is a static plus velocity pressure. So for that, each pitot tube will have 2 sets of tubes. Like this, this is for measuring the static and this is for measuring the total pressure. So here again, these 2 tubes, one will be along the direction of flow, other will be against the direction of flow. So this will measure total pressure, and this, which is on the opposite side of the flow, it will measure the static pressure, because the velocity is not going to get impinged on that. But here it will get impinged, it becomes 0. So here it will get converted to, and total pressure will get. Now in this also, there's a tube, and there are 2 tubes, one in another, which you can see from these 2 things coming out. So it will again same way measure the static and total pressure, and difference will give you velocity pressure, which will be again calibrated with a digital pressure gauge or any digital system to give you directly velocity, or it will give pressure. You can use the pitot tube formulae to calculate the flow. Then we come to digital manometer. Manometer is to measure the pressure. Basically, this is mostly used for efficiency of the fans. So we need to measure the suction pressure and discharge pressure of the fan. For that, we use digital manometer. It is also used along with the pitot tube, but that is a different range. With pitot tube, the delta P is very small. It may be 10 degree, 10 or 15 kind of thing. So we have a small digital manometer, as I said, because that accuracy range and all. We have a specific separate manometer only for pitot tube, having very small range and higher accuracy. And for fan, we have a different manometer. Then it is also used to do pressure mapping, because many times it becomes important to map the pressure in the duct, along the duct, especially if the ducts are long. Or say there are different equipment, like you have boiler, economizer, air preheater, then there is a ESP and all kind of thing. So there we want to find out what are the pressure drop in the individual equipment and what is the pressure drop in the duct. Now there are cases where even a damper, if it is got stuck internally, it can have a pressure drop. We have seen a pressure drop across the damper to be as high as 100 mm water column, which was 10% of the fan power, because the total fan was developing 1000 mm and 100 mm was lost in a damper because it had got stuck. From outside it was looking as if it is open, but it was stuck internally, and that connection was damaged or broken, and it was having 100 mm. So along the duct also we need to do measurement. For that, digital manometer is used. This is not a very problematic thing. You can use, it's very easy to use. Only thing we have to see that it is not clogged, tubes are not bent, because if it is bent, the rubber tube or plastic tube, if it is bent, it is not going to show anything. It may happen. So these are the things why we need to take care. These are the manometers. This is olden type. I think YouTube nobody uses now, using this digital manometer of different ranges. We have digital manometers of 3 ranges. One is up to 0, another is 1000, and another is 2500. Again, for the same sake of accuracy and correctness of the reading. This is another instrument we need to be very, it is used extensively, especially when you are doing HVAC studies for the offices, textile industries. It measures dry bulb temperature, that's the temperature of as it is, and it measures relative humidity or wet bulb temperature. So relative humidity is the humidity with respect to, and based on that we are doing calculations on performance of the HVAC system, the hall condition, the comfort level, and all that things. So this is also a very simple instrument that way, not very expensive. And this also has, you have a lot of loggers available, because of this requirements now that HVAC load is going up. The loggers for temperature RH available at as low as 2000 rupees, 2500 rupees, where you can place them wherever you need, and you can have a 24-hour data which can be transferred to your Excel sheet for analysis to see how the temperature and humidity varying along the day and night. So we do it while we are doing studies for the cooling tower, or sometimes even for the call center, the data center or service rooms, server rooms, where the criticality is there. Now, the most important thing what we have to do is we have to wait for the reading to stabilize, because RH, as I said earlier, also takes a lot of time to get stabilized. So otherwise the reading won't be correct. And another problem I have seen extensively is there is a limit to which the instrument will work, especially on RH side. Now, some of the instruments say 95% non-condensing, some of them say 100% non-condensing. So if it is condensing, if you try to measure it just at the AHU outlet, sometimes there are some water droplets. They go inside and then clog it, and you don't get any reading. So it has so happened that despite having hygrotemp of 2-3 types, we had used psychrometer to do the temperature RH measurement at some places, because it was carrying a lot of water, especially the chill water system where the chill water is directly spread. So humidity measurement is not possible. Within a minute, the instrument will get 0 reading. Take it outside, dry it, the probe will again start showing. So it doesn't damage the probe, it just doesn't show the reading. So you have to see that you are operating within those limits. Another is that psychrometer, very old instrument. It will measure dry bulb and wet bulb temperature. We are still using it for cooling tower many times, because cooling tower at the top, when we are doing the exhaust air analysis, we use ceiling psychrometer for the same reason as I said, because any hygrotemp meter will get locked if the probe gets wet. These are two instruments. This is where that this is normally say 100% non-condensing, maximum what we have seen. So any condensation means it will just get locked. It will not show the reading. So this is the swing psychrometer. This is probably for the dry bulb where it is just exposed to atmosphere. This has a wick which is supposed to be wet, so it will be always wet, and that will reduce the temperature to wet bulb value. This is a chart you must have or known about it, so I'm not going to cover much about it. And as such, now there are a lot of software available. So this is only taught probably in colleges. Now in industry, we always use the software. All software freely available. There are add-ins for the Excel which will directly calculate. So psychometric charts are normally not used in audit. They always have some software and some Excel add-ins. Based on that, they do the calculation. But basically, what it means is if you know two parameters in this, all other can be found out. If you know temperature RH, you can find out what is the wet bulb temperature, what is the enthalpy, what is the dew point. Similarly, if you know anything else, also you can find out other things. If you know wet bulb temperature and dry bulb temperature, you can find out RH, you can find out enthalpy, near else. Then there are clamp-on meters. These are actually most critical instruments because major savings or major audit is on a electrical side. All said and done. Thermal side becomes relatively, one is boiler efficiency, then trap performance, and condensate recovery. So trap performance, condensate recovery is okay. So, but major saving, major analysis of the auditor, 70% of the time is normally spent on electrical system measurement, and all electrical related saving can only be through power measurement, because ultimately what we are going to save is in terms of kilowatt. So there are some 3-4 types of energy meters available. Now, for a single phase load, that is basically the 230 volt supply and a neutral. So there are instrument with one CT and voltage probe for a neutral and fades. So it is very simple. You have a CT, and here again, most of the cases we want to do the measurement without disturbing the operations. Because every time, suppose you have to for connecting a CT, if you have to stop the machine, disconnect the cable, it is not possible. So these are all clamp-on type meters, and one CT, and two voltage probe, one for voltage and another for neutral. That is a common instrument used for measuring the single phase load. There is another meter which is used for single phase smaller load, is a plug-in meter. A plug-in meter, I think Ashok showed towards the end of the slides. It is just you plug it in a socket. The meter also will have a socket through to which you connect your cable and load. So it will show you all electrical parameters, and you can note it down. Like we do it for doing audit of say air conditioners, or you want to know what is the power consumption of a oven, mixer, or anything else, then you can just use a plug-in meter available. I think now it's available on Amazon also, and you can do the measurement. A plug-in meter can also be made. We had got it made ourselves earlier for certain application, because industrial sockets, you don't have plug-in meters for industrial sockets. At least I am not aware of. So we had made a board with energy meter and industrial socket, and then cable connect. So whatever is the cable, it will come to the board through meter, and through this it will get connected to the industrial socket or normal socket. So depending on whatever the socket is there for that load, we used to connect it through our board and do the measurement. So this is basically for smaller loads. We talk about maybe 2 kilowatt, 3 kilowatt maximum, or smaller is even you can measure for laptop also. My laptop also had done the analysis. It was consuming some 9 watt or 10 watt. So I just wanted to see how much is the consumption of laptop in different modes. People keep saying go to sleep mode, go to this mode, reduce the brightness, increase this. So I just wanted to measure the power consumption at different condition. So I had done that. You can also do it for your college. You will come to know that how much can be saving by putting the monitor to sleep, or maybe the putting the laptop or the CPU to the sleep. How much is the actual consumption? Again switching off, again running it in a screensaver mode. So that all can be done with plug-in meters. And the other thing, mainly industry, what we are using is three-phase balance load. Normally three-phase, there are two types of loads. One is a balance load where the load is expected to be same for all the three phases. Like motors, all the motors are expected to have same current, same power consumption for individual phases. So this is what is called as a three-phase balance load. For that, there is a simplified meter which will have one CT, because we are assuming that all the three phases load is same. What we do is we measure the current only of one CT, one cable, and measure the voltage for two phases. Now those two phases, depending on the meter, it can be the two different phases. Like if you're measuring the power consumption in R phase, then there could be voltage could be connected to Y and B, or it could, there are some meters which will say R and Y. So you go as per the manufacturer directive and connect the voltage probe. So based on assuming that all the three phases are having same load, it will give you the data. It will give voltage, current, power factor, harmonics, everything it will give. So life becomes slightly simplified, because if you have to carry and use that three-phase unbalanced load meter, installation connection takes much more time. It's not just that you have to connect three CT, they have to connect three voltage probes. Sometimes there are four CTs. So it would take almost 3 to 4 times of time. So normally for motors, what we do is we do it with three-phase balance load meter, and this also is available from anywhere from 7,000 rupees to 50,000 or 60,000 rupees. So depending on your requirement and application, you can select what kind of meter do you need. Most of the meter will have similar accuracy, of course. The workmanship and other thing could be different. Now this CT is available in 2 or 3 different ranges for the three-phase balancer. It could be 600 ampere, it could be 300, 100 ampere. So that we need to be slightly careful when we are selecting the meter. What is the maximum current, or what is the maximum load we are going to measure with this, and accordingly need to select the meter. Otherwise, as I said earlier also, you have 600 ampere CT and you're measuring 20 ampere, 5 ampere or 6 ampere, it will not come correctly, and there could be an error. So we should have accordingly selected the CTs for this. And the higher end meters, they have a clamp-on CTs, so that CT can they have attached detachable CTs. So the CT, you can have more than one CT connected to that. They are 0 to 5 ampere. There is a CT 0 to 100 ampere. There are CTs. So accordingly, you can do the selection for a three-phase balance load. The third is three-phase unbalanced load or unbalanced. Like even balance load, you can do the measurements. The load is big, HT motors and all. When we are doing audit, we use this third meter. It will have 3 or 4 cities depending on the meter you buy. Four city will be expensive. It will measure the current in the neutral also. Otherwise, it will assume that neutral is 0 and it will measure three-phase voltages, three-phase current, and based on that, we'll do the measurement. So this is more accurate because it is measuring all the parameters, all the three phases current, all the three phases voltage. But it is more expensive. It is more tedious to connect. These are available, I think, from 50,000 rupees to 10 lakhs, depending on what kind of measurement you're doing. Because here, what happens, when you are buying this, you always are looking at the sampling rate, because how many readings it will take per minute or per second. So normal standard meter is available which will measure the data every second. So you'll have all data values for every second of time. Now that is sufficient for most of the audit measurement. But if you are trying to measure the power quality, then power quality needs transient. If you are trying to measure, it needs much more higher sampling rate. So there are instruments which will measure transient and other things, spike, transient, all that, but there the sampling rates are higher. So that is where you need to basically make a distinction. If you are doing a power quality analysis and other analysis, you may need to go for a higher sampling rate instrument. But if you are just measuring the electrical power harmonics, then 1 second measurement is good enough. Of course, they are selectable, not that you have to 1 second means you have to go for 1 second, or the fraction of second means you have to go for fraction of second. This all times are selectable, and you can select according to your requirements. So the plug-in meter already talked about. So the basic precautions here are, you have to configure it properly. The phase sequencing and current direction has to be correct. If you don't see the sequencing is not correct, of course the meter will show that it is here. There's no problem. Phase sequencing and that everything will be there on the meter. It will be shown by a diagram, and you can connect that. Current direction you have to physically see and do it when you are clamping the CTs. And another precaution, especially we have to take, especially for the phase, the star delta connected motors, is you should connect the meter in line, before the split. Otherwise, there are 6 cables going to the motor. If you try to connect in a phase, and if you do it in one of the cable, it is not going to give correct reading. So you have to connect it before the cable are split. Star delta connector, you have to do it at the incoming, so that you get a line current and related parameters. Apart from that, of course, safety precautions and all we anyway need to take. You don't have to tell you separately about that. These are meters again from the internet. This is the meter with this is the expensive one. We use this. This is with single CT and 2 voltage for a 3-phase balance load, or you can also measure single phase load with the same one. Now here this CT is small. For this again you can have a higher current rating capacity. This is 0 to 5 ampere or 0 to 100 ampere. It has a selectable switch, and then there are flexible CTs which can measure up to 6,000 amperes. They are available in different sizes and different this one. So depending on what measurement you are doing, you have to select the CT. You can have more than one set of CTs. Now we have 4 sets of CTs: 6,000 amperes, 3,000 amperes, 1,000 amperes, and this small one for this one. So 4 sets of CTs are what we have, but depending on where you want to do audit, you can select the CTs. This is the enlarged version with 4 CTs. Here again you have, because these are attachable CTs, you can select the different rating CTs, same as the other meter. This is the cheaper one. This is coming as a single unit, like a tongue tester with voltage probe. So it will give you. You just clamp it for one phase, and other to connect the voltage to get the reading. This is cheaper one. This is more expensive, and this is the most expensive. Of course, here again you get different types depending on the sampling rate and other parameters. This is a plug-in meter. I think this is simple. You have taken it probably from Amazon, and many of these meters are Chinese, so you have to have adapter here. You cannot directly connect it. This is ultrasonic flow meter. This is slightly tricky instrument because it has a it's slightly more complicated working principle, and there are 2 types available. One is for clean liquids. It is called as a transit type ultrasonic flow meter. Another is for dirty liquids. Dirty in a sense it contains certain either air bubbles or suspended solids. So that is based on a Doppler effect, and this is based on transit time. So basically the principle is very simple. There are 2 probes which are to be mounted on the pipe. The pipe has to be first clean. You apply grease to eliminate any air gubbers, air gap, because that is required. If there is air gap, the signal won't transmit through. So these 2 probes will emit ultrasonic signal. So each probe is a or a transducer is a receiver and emitter. So it will emit the sound, it will also receive the sound. So basically, this is a transit type. So what happens is both these transducers are emitting and receiving the sound. So whatever is emitted by this will be received by this. Whatever is emitted by this will be received by this. So they act as a emitter and transmit. So one signal is going along the direction of flow, another is going against the direction of. So the difference between these two signals, one signal is going against, another is going along the direction. So there is going to be a difference in the travel time depending on the velocity of the liquid. You can imagine that difference would be very small. The diameter is small, everything is small. So difference is very small. So how accurate the instrument has to be. That is basically the trick of that instrument. That it is in maybe nanoseconds or whatever kind of thing. It is that is the kind of difference you are going to get. And based on that, it will calculate velocity of the liquid. Now, one need to be careful about this because, as I said, readings can be erroneous. Because as such, the signal received back is very small. Less than a percent of what you are emitting. Now, in that, if there is error, the reading cannot be correct. So we have to ensure that we are following the method correctly. Installing the meter correctly, and the pipe is cleaned. If the pipe is not clean, if there are scaling on the pipe, either internally or externally, it is going to affect the measurement because the signal is getting bounced. And you all know that if the surface is rough, it is going to bounce. Like that's how the spin ball works. That if it's a rough surface, it is going to unpredictable return path. So that is where the problem can be. The good thing about this instrument is it will give indications. If the readings are not coming, it will give an indication. It will give what is the signal strength you are receiving. It will also tell you what should be the difference between the two probes. And accordingly, you have to set the probe. So that part is made easier by the instrument. It is programmed. So you key in the pipe diameter, pipe thickness, and type of liquid. Based on that, it will tell you what is the distance between the two probes. And you close the probe accordingly and wait for the signal. So there'll be a signal which will tell you that you can rely on the reading. If the signal is not received, you can still adjust the distance between the two probes, because what instrument is giving is slightly indicative. So you can adjust the transducer distance so that the signal is appropriate as per the requirement of the instrument. And based on that, you can get the flow rate. So instrument will tell you if the reading is correct or not, if you're getting the reading or not. But as I said in the beginning, now it will not tell you if there is a eddy current inside. So if you don't select the straight length properly, it is not going to tell you that you're not selected the straight length. But if the instrument probe distance is not correct or signal is not received properly, all that will be indicated by the instrument. To that extent, these instruments are good. They will help you. There are a lot of functions available with which the reading can be correctly obtained. But other things we need to be careful about. The diameter has to be keyed in. So we have to properly key in the diameter. If the diameter is wrong, the flow is going to be wrong, obviously, because the diameter flow is proportional to square of diameter. So the error in diameter will get magnified. Now, Doppler effect is, as I said, it is for suspended particles, liquid having suspended particles or bubbles. Now, this basically, there can be one transducer or two transducers depending on the instrument. There are instruments available with one transducer, which are slightly cheaper, and these are slightly more expensive. Rest of things are same. The functioning is based on the Doppler effect. That's a shift in the wavelength of approaching and leaving the sound source, and based on that we'll do the measurement and tell you what is the velocity. These are the precautions. I think first one I already discussed with you. Diameter has to be correct, of course, I said that. Then the pipe should be filled with liquid. This is very essential. Sometimes people have a tendency of taking it on a vertically down pipe which is falling in a cooling tower. If it is vertically down connected to the in a continuously pipeline, it is all right, it will have a filled in one. But if the liquid is falling in an open pit, then it may not be filled, that pipe may not be filled with liquid. So it has to be filled with liquid, otherwise the reading won't come. The pipe external surface should be clean. Grease should be applied properly so that there are no air gaps. The probe should not be placed on the top or a bottom of the pipeline for obvious reason. The top and bottom, normally bottom is normally more corroded, top may have some issues. You should always go for a lateral surface. Clamp the probe securely. And as I said initially also, that if you have a doubt that flow shows fluctuation, and there are many times there are fluctuations in the flow for the process reasons, then you take a totalizer for depending on the time available and depending on the variations, you can take it for 5 minutes to 2 hours, whatever is convenient. These are the flow meters. Now there are ultrasonic flow and energy meters also there. Now the working principle is same. There's no much of difference, but it also has two RTD sensors, which can be at the inlet and outlet of the equipment. So it will measure the temperature. The temperature data will go to the same meter. It already has flow. You key in the density and specific heat of the liquid, and it will calculate TR, kilocalorie, BTU. It will be provided to you. So these are also, we are using it now for doing the load balance, or sometimes even the chiller performance logging. We are doing this so that you can get all the values on a 24 hours basis. Take the flow, take the temperature, and take the power. So all the parameters are logged for 24 hours. And based on that, then we can give better suggestions and profiling. PTO meter. Pressure gauges, manometers are all the same family. Pressure gauges for higher temperature values, manometers are for lower values. So all we use is digital, and I think most of the auditor have digital instrument only now. It basically for a pump performance, sometimes compressor performance, and pressure drop in the pipeline. This is basically because distribution system also becomes very critical, especially when have a long piping length, or you have multiple AHUs. Like pharma industries, where they have 100, 200 AHUs, the distribution line can be very challenging. They may not get water flow at certain points, at the extreme ends. So what we do is we do the pressure measurement to see the profiling of the pressure across from the primary pump, secondary pump, then to the first AHU, third sets of AHU, to see if the pressure values are appropriate. Can also calculate the pressure drop in the individual equipment to see whether it is as per the design values or not. So pressure gauges are used extensively. Like we use it in power plant. It is very common to find out what is the pressure drop in a condenser, because that is how that is heart of the power plant. If the condenser is clogged, if this pressure drop is higher, the flow is less. Correspondingly, you won't get the vacuum, and the heat rate will go up, and ultimately turbine performance will drop down. So pressure drop measurement also becomes critical. So is the pump performance. For that, pressure gauges are used. Now, basic precaution is basically there should not be leakages, because if there's a leakage, the reading won't come proper, and there should not be clogging in the tube. It's a main. These are the pressure gauges. Probably would have seen. Mostly we use digital, this type of instruments. A different range again we have for one is up to 5 kg range, another is up to 25 kg. So 2-3 ranges we have depending on the application. We use them. These are basically some instrument what are used for leak detection. This is very good instrument actually, and we are using it now extensively. It is basically to determine if there are any leakages in the ultrasonic in a compressor or nitrogen line, because compressor leakages, it's very difficult to gauge. All said and done, plant is a very noisy place. You already have multiple noises, so you will not be able to hear the noise of a compressor leak. But this ultrasonic leak detector can detect and identify the noise, a leakage through noise. It will not quantify. There are some instruments which also quantify and tell you how much is the leakage, but I don't go by that argument, because it's very difficult to quantify. It can tell you whether it's a minor, major kind of thing. Object subjective analysis can be done, but it cannot quantify the number. But there are instruments available which will do whatever their algorithm and logic is and tell you what are the losses through the leakage. It can also be used for steam leakages, especially superheated, because superheated steam leakage is not visible. It can also be used for steam trap functioning, because steam trap also, when the steam trap discharge, there's a peculiar sound. So if that sound is again picked up by the ultrasonic meter, and we can use it for trap functioning. One need to be slightly careful when using a float type trap, because that time some of the traps are continuously discharging and the read may not be correct. But this coupled with thermography can tell you the trap health. So we normally do this trap testing with ultrasonic plus thermography to get correct values. It will also give abnormalities of the drives, because if there are drives, there is some misalignment or any issues, the sound will be of different types. There are specialized gadgets made only to do this test also, but our normal ultrasonic detector also can do the functioning. May not be as accurately, but it can be sufficient for us. Now, this is main precaution is basically you should use the noise cancelling headphone, because they provide a probe, and you can take that probe, and they keep saying that it can measure even up to 3 meters. Some probes say 6 meters, but that is more of a eyewash. So always use a noise cancelling headphone, so you can also hear that sound along with whatever is the digital display, or there is a deflection or whatever that shows with the probe. So because we have to use a noise cancelling headphone, the operator needs some training. You just cannot, anybody just cannot go it. It needs a training, maybe about 2 to 3 hours on how to use the instrument. These are the typical instruments. These are all slightly cheaper version. What we have is a more expensive. Then we come to flue gas analyzer. Flue gas analyzer basically it will measure temperature, oxygen, and carbon monoxide. Then, of course, there are probes available which will measure NOx, SOx, and all that. That can be added if it is required. But from energy audit point of view, most critical things are temperature, oxygen, and carbon monoxide. Carbon dioxide contents are normally for electronic gadgets, they are calculated. They are derived based on the fuel composition. So this, most of the instrument carbon dioxide contents are not correct, because it all depends on the basically the composition of fuel. What BW formulas will tell you, same thing they do based on some assumed composition of coal or maybe fuel, depending on the selection of fuel. But that is if the carbon is different in our case, then the readings are going to be different. So carbon dioxide is not actually measured, but oxygen, carbon monoxide, and flue gas are measured, and based on that we can calculate through BEE procedure the efficiency of the combustion efficiency. And other combustible can be added. Now, if somebody really wants to measure carbon dioxide, then you can go for a basic instrument, that is ORSAT, which is still available, and do that measurement. But nobody does it for audit. Select the location properly, as I said, because earlier also I was saying that this becomes a very critical thing. Insertion should be sufficient. I explained in the beginning that if it is not sufficient, the reading could not be correct. Air ingress and sufficient time to stabilize. These are the flue gas analyzer. These are all with smaller probes. What we have is almost 700 mm and 1 meter. infrared gun. This is basically now mostly it is outdated, but still some places we use it. This is a non-contact device to measure temperature with infrared spectrum. You know, the 0.7 to 0.8. I think is 80 is wrong. 0.8. So this is comfortable because we don't have to touch the surface. Otherwise, with RTD, the thermocouple, we have to physically go and place it on the surface. This can be taken from distance. It can be used for low temperature. Is of course you can measure it up to 800, 900, even 1000 degrees are available. But this is the infrared temperature use. So you need to correctly select the emissivity. That's the most important thing. The location should be correct because the distance, as the distance increases, the total target window increases. You know, if you're taking from long distance, you're reading that the total area of surface area becomes very large. If you cannot go very close, the reading may not be correct. But that is the thing we need to be careful, and it will be indicated also in the by OEM that this is the these are the values, and target should be completely filled in the view. These are the infrared temperatures. Again, these are available in different ranges. We have three ranges. We have something up to 300, 600, and 900. You know, because again the errors part. Pyrometer is similar one for higher temperatures. It uses visible light spectrum and higher temperature. You know, you can measure up to 700 degrees. This is used for basically measuring the flame temperatures, furnace internal temperatures, or opening losses and all that, where the temperatures are higher. You know, furnace temperatures be 1500, 2000, somewhere even 7000 is very rare. But 2500 typically can be a flame temperature. If you want to measure such kind of values, then you need a pyrometer. Similar care you need to take. Thermal imager is another extensively used instrument. Ashok already spoke about it. Now it captures visual and thermal image. That's the advantage. You know, you have a visual image also, so that you know how it looks normally and how the thermal profile of that image looks. So based on that, you can identify the locations where the image could be, where the temperature is on higher side. It'll give a complete profile of the surface. Like unlike infrared, you know, infrared will give you a point value. It will give you the temperature of entire surface in a image form. So you can correlate, you can analyze it later. You can do a lot of editing. It is very extensively used for all kind of applications. Electrical panel, that's how it all started. So you can do it for electrical panel. You can measure surface temperature. We are doing that now. All pipeline measurements, cold pipeline, hot pipeline, anything, any pipeline, furnaces, we do that. Here again, there are ranges. We have one up to 150 degrees, another up to 250 degrees, third one up to 600 degrees. So those thermal images what we have, and different areas we use this. Heat air ingress also can be like, you know, you take an image of a door. Now if it is a cold storage, you take the temperature of if you take the door image, you will know if through the gap, if the something is going in, again that will be at higher temperature. So that will tell you. Even normal windows, you know, like HVAC office windows also, we have done thermography to find out the leakages, ingress points and all that. Steam trap testing, I told you already. Motor temperature profile, I think Ashok had already mentioned. Bearing temperatures, even seepage to buildings can be measured, you know, because there are thermal images available with 0.1 degree difference. So you can do that measurement. And specifically, there are thermal imager available for building audit. We don't have that, but it is available. Basically, the precautions are not much you need to do. Emissivity has to be correct, and distance should be correct, because the thermal imager has a limit on the distance. You cannot take it from 6 meter or 5 meter or 10 meter distance. So you have to maintain that distance. These are the thermal imagers, very handy instrument, and they are available, I'll tell you, from 25,000 rupees to 10 lakhs. Now they are available, and it's from a good company, Fleur, which is attachment to your mobile. So you can connect it to the mobile, you know, and click. It has an app, so you install that app, connect that device, and you can record, you can have image, you can video record the profiling of the temperature, and it has a range of, I think, 150 degrees. I have that instrument and I use it. We have even used it for cooling tower, to study the distribution of water and temperature profile of the water which is falling in the cooling tower. We have taken thermal imaging of that falling water and see if the distribution is proper, cooling is proper or not. These are thermometers. I don't have to say much about it. It is for measuring the temperature, reading to stabilize, standard. Tachometers for measuring the RPM. So they are available in contact and non-contact type. RPM measurement becomes critical, especially when you have a belt-driven equipment. Of course, belts are getting outdated, but still, some cases you have belt-driven equipment. Now, if the belt is loose, there can be a slippage, and the extent of slippage need to be measured. So for that, we need to have measurement. You measure the motor RPM, you measure the equipment RPM, and take the pulley ratio. Based on that, you can find out theoretically what should be the RPM and actually what is the RPM. For that, tachometers are available. Now again, tachometers are outdated, we don't use it. But just for you to understand this, there are two types, is non-contact type and contact type. Contact type is directly you have to connect it. Non-contact, you have to put some tape on the rotating surface. That becomes impossible because for that you need a stoppage. So that's how we stopped using it. What we use is a stroboscope. Stroboscope is also needs a specialized some basic training, but that is again a very good instrument. It will tell you RPM very correctly. It also tells you vibration. We don't use that, but you would be aware of the stroboscope. Basically, it emits light at certain frequency, which can be adjusted. And that when you adjust the frequency, you will see that the rotating object is actually stationary. So we adjust the emitting frequency such that rotating objects appears to be stationary, and that is the RPM. So it is very comfortably, you can do it and there's no problem on that. And there again, there are two types of adjustment available. One is a coarse adjustment to make a rough adjustment, because if the RPM is some 900, it will not start from 0, 1, 2, 3, 4. You can directly go to 800, 850 and then slowly fine tune it. So those are available with the instrument. Only thing is you need a very clear unobstructed visibility, that is anyway required, otherwise you can't do that. And because it needs adjustment of the light emission frequency, the auditor needs some training. These are the stroboscope, very very good instrument. We use it regularly. Tachometers are practically outdated for us. Now probably this is the last instrument. Sorry, I've taken a bit more of time, but this is for measurement of flow, gas or air. Now I'll tell you on the onset, this is very complicated instrument because it is an insertion type. All whatever we have seen normally are non-insertion type, except for hot wire anemometer, but that and pitot tube, but that is again very small pressure, so it doesn't matter. But compressor is operating at 7 kg, gas can be at higher pressure. So thermal mass flow meter is insertion type. That makes it very complicated because at 7 kg pressure pipeline, we need to insert the probe. Now to inserting, there is a provision, there are two sets of walls and you can insert it without any accident, but there are chances of accident happening. Plus sometimes the readings are not so accurate and people keep on objecting to the values, and we have seen it happening with a big organization. So we don't have this instrument and we don't use it, but just in case you need to use it somewhere, these are available for measurement of flow, compressor and gas at higher temperature. Now the working principle is similar to what we talked about anemometer, but it is a more sophisticated, more expensive thing. This one. So they'll have two probes. One will measure the temperature. Another will emit a current, either constant current or varying current and constant temperature. And based on that, we'll measure the MCP delta T will tell you what is the flow rate. So this is the working principle. This is how it will look. The two probes are there with some heat injection, which will and the temperature will be measured. Based on that, it will be calculated. Now, unfortunately, there are no flow meters, ultrasonic flow meters available for compressed air. There are ultrasonic flow meters available for higher pressure, this one, but they are not available for compressed air because they have some density issues. If they say that this is the pressure, this should be the pipe size, so effectively it rules out any ultrasonic flow meter for compressed air. We tried a lot. There are two companies who are making it. One is G, another is Flexim, Germany. But we are not able to get anybody giving a demo. We don't mind buying it, but thermal mass flow meter has its own limitations. But it is available. If somebody tells you to do measurement of compressed air flow rate, you can go with thermal mass present. There are other things we don't need to talk much. Measurement tape, scales, then stopwatch. Stopwatch is also gone now. We all have now mobile. Weigh scales, distance meter also you have digital available so that you can measure the distance without putting a tape. Cameras, some people want to take a photograph of what is wrong or how it is to be improved, especially when we are doing electrical audit. So we carry, again, digital camera is now mobile only. Then data loggers are there, which is now a coming up thing because people are not happy with one point measurement. So data logging, we can have sensors and data loggers, and all the same measurement can be done for a longer time. With this, I conclude my presentation. Let me know.